Welcome back to this math channel. This time, let us discuss geometric sequence. Before we continue, let us recall an important concept. If A and B are two non-zero real numbers, the ratio between A and B is the quotient A over B in simplest form. The ratio of 10 to 12 is 10 over 12, can be simplified as 5 over 6. Also, the ratio of x cubed to x is written as x cubed over x and simplified as x squared over 1 or x squared. Let us proceed to some definitions. A geometric sequence is a sequence in which the ratio of consecutive terms is a constant. This constant is called the common ratio. The sequence 3, 6, 12, 24, and the pattern continues is a geometric sequence, since each term after the first term is obtained by multiplying the preceding term by a constant. The constant is usually denoted by R, and R may be found by getting the ratio between consecutive terms, such as 6 over 3. It must also be equal to 12 over 6, also equal to 24 over 12, so R is equal to 2. Hence, in the geometric sequence 3, 6, 12, 24, and the pattern continues, R is equal to 2. To find the formula for the nth term or the general term of a geometric sequence, we use the idea that any term after the first term is the product of the preceding term and the common ratio. Let a sub 1 be the first term. To find the second term, that is a sub 2, we multiply a sub 1 by the common ratio. Let us denote it by R. The third term will be a sub 3 equal to a sub 2 times R. But a sub 2 is equal to a sub 1 times R. Hence, we can write a sub 3 in terms of a sub 1 and R as a sub 3 equals a sub 1 R times R, can be simplified as a sub 1 R squared. Let us proceed to writing the fourth term. We have a sub 4 that is equal to a sub 3, the previous term, times the common ratio R. In terms of a sub 1 and R, we know that a sub 3 is equal to a sub 1 times R squared. Hence, writing a sub 4 in terms of a sub 1 and R, we have a sub 4 is equal to a sub 1 R squared times R. So we have a sub 1 times R cubed. Notice that each term in the geometric sequence after the first term, a sub 2 is a sub 1 times R with R raised to 1. A sub 3 is equal to a sub 1 times R squared, where the exponent 2 is 1 less than the subscript n, or the number of terms. A sub 4 is equal to a sub 1 times R raised to 3. Again, notice that the exponent is 1 less than the subscript, or the number of terms, n. Hence, we can simply write the fifth term in terms of a sub 1 and R. That will be a sub 5 is equal to a sub 1 times R raised to 5 minus 1, and that will be a sub 1 R raised to 4. To write the nth term of the geometric sequence, therefore, in terms of a sub 1 and R, that will be a sub n equal to a sub 1 times R raised to n minus 1. And this is the formula for the nth term of a geometric sequence where a sub n is the nth term, a sub 1 is the first term, n is the number of terms, and r is the common ratio. Let us have some examples. Write the next three terms in the sequence 2, negative 6, 18, negative 54, and the pattern continues. To write the next terms in this geometric sequence, we find the common ratio by getting the ratio between consecutive terms. So we have r is equal to negative 6 over 2. That is the second term over the first term. And this is equal to negative 3. We can check this by multiplying each term by negative 3. So we have 2 times negative 3 is negative 6. Negative 6 times negative 3 is 18. 18 times negative 3 is negative 54. Hence, the common ratio that we have is correct. That's negative 3. Also, it can be checked by getting the ratio between any term and the previous term. Let's say negative 54 over 18 is negative 3. So the common ratio is negative 3. Hence, to find the next three terms, we already have 4 terms in the given geometric sequence. So to find a sub 5, we have negative 54 times the common ratio, negative 3. And this is 162. Next, a sub 6, that will be 162 times negative 3. And this will be 162 times negative 3. We have 6. 6 times 3 is 18. 1 times 3 is 3 plus 1, that is 4, negative. So a sub 6 is negative 486. A sub 7 will be negative 486 times negative 3. So we have 486 times 3. So we have 18. 8 times 3 is 24 plus 1. 4 times 3 is 12. That is 14. Positive 1,458. Hence, the next three terms in the given sequence are 162, negative 486, and 1,458. Next example, find the 11th term in the sequence 2, 10, 50, 250, and the pattern continues. Let us check whether this is a geometric sequence. So we have r is equal to 10 over 2. That must be equal to 50 over 10. That is equal to 5. Hence, we have a common ratio. This is a geometric sequence. And to find the 11th term, we have a sub 11 is equal to a sub 1 times r raised to 11 minus 1. Substituting a sub 1 is equal to 2, r is equal to 5, and n is equal to 11. So we have the 11th term as equal to 2 times 5 raised to 10. So that will be equal to 2 times 5 raised to 10 is 9,765,625 using a calculator. So a sub 11 or the 11th term is equal to 19,531,250. Example number 3. In a geometric sequence, a sub 5 is equal to 112 and a sub 7 is equal to 448. Find a sub 1 and r. Using the formula for the nth term of a geometric sequence, we write the formula for a sub 5 and a sub 7. So we'll have two equations in terms of a sub 1 and r. And then we're going to solve the two equations simultaneously to solve for a sub 1 and r. Let us begin with a sub 5. First, let us have the formula. We have a sub n is equal to a sub 1 r raised to n minus 1. So for a sub 5, where n is equal to 5, we have 112 is equal to a sub 1 times r raised to 4. That is from 5 minus 1. Let us call this our equation 1. Next, for a sub 7, let us have an equation that will be 440a is equal to a sub 1 times r raised to 6. Let us call this equation 2. The exponent 6 in equation 2 is obtained from 7 minus 1. That is n minus 1. Now we have two equations in terms of a sub 1 and r. To get the value of a sub 1 and r, let us solve the two equations simultaneously. Let us divide equation 2 by equation 1 to eliminate a sub 1. So we have a sub 1 r raised to 6 equal to 448. This is from equation 2 divided by a, that is a sub 1 r raised to 4 is equal to 112. Dividing these two equations term-wise, we will get a sub 1 over a sub 1 is 1. So we have r squared, that's r raised to 6, divided by r raised to 4. We subtract the exponents, r raised to 2. 448 divided by 112, that is equal to 4. Hence, r squared is equal to 4, and to get the value of r, we have r is equal to positive negative 2. We will use only the principal root, so r is equal to 2. To find a sub 1, we substitute r equals to either equation 1 or equation 2. Let us use equation 1. We have 112 is equal to a sub 1 times r, that is equal to 2, raised to 4. So we have 112 equal to 16, that's 2 raised to 4, a sub 1. Dividing both sides by 16, we have a sub 1 is equal to 112 divided by 16, that is equal to 7. Therefore, a sub 1 is equal to 7 and r is equal to 2. And let us proceed to geometric mean or mean proportional. Geometric means are the terms between any two given terms of a geometric sequence. In the geometric sequence with terms negative 4, 16, negative 64, 256, negative 1024, and the pattern continues, the terms 16, negative 64, and 256 are the geometric means between negative 4 and 1024. If a and b are two real numbers, then the geometric mean or mean proportional between A and B is given by the square root of A times B. Let us have another set of examples. Example number 4. Insert 4 geometric means between 3 and 96. Let us have our solution. In here, we are asked to insert 4 geometric means between 3 and 96. So that means our first term is 3. Then we have 4 terms. Then we have 96. Hence, if 3 is our A sub 1, then 96 is our A sub 6. We will be able to insert the geometric means between 3 and 96 once we know the common ratio of the geometric sequence. Since we have A sub 1 and A sub 6, we can get the value of R, the common ratio. The formula for A sub 6 is A sub 6 equals A sub 1 times R raised to 5. Substituting A sub 1 equals 3 and A sub 6 equals 96, we have 96 is equal to 3 times R raised to 5. Dividing both sides of this equation by 3, we have 32 is equal to R raised to 5. To get the value of R, we get the fifth root of both sides. The fifth root of R to the fifth is R, and the fifth root of 32 is 2. Hence, the common ratio of this geometric sequence is 2. So we can now insert the 4 geometric means between 3 and 96. A sub 1 is 3, then A sub 2 is equal to 3 times 2 raised to 1, and that is 6. A sub 3 is equal to 3 times 2 raised to 2, that will be 12. A sub 4 will be 3 times 2 raised to 3, and that is 24. A sub 5 is equal to 3 times 2 raised to 4, and that is 48. Hence, the 4 geometric means between 3 and 96 are 6, 12, 24, 48. To check our answer, let us multiply 48 by the common ratio, and the answer must be 96. 48 times 2, we have 96. Let us have another example. Insert 3 geometric means between 2 and 162. In here, we're going to use the same solution. So we have 2, and then we have 3 terms after the first term. Then we have 162. Hence, in the geometric sequence, we have A sub 1 is equal to 2, and A sub 5 is equal to 162. The formula for A sub 5 is A sub 5 equals A sub 1 times R raised to the 4th power. Substituting the values, we have 162 is equal to 2 times R raised to 4. Dividing both sides of this resulting equation by 2, we have 81 is equal to R raised to the 4th power. To get the value of R, we will get the 4th root of both sides of this resulting equation. 4th root of R raised to 4 is R. The 4th root of 81 is positive negative 3. Hence, inserting an odd number of geometric means between two numbers will result to a common ratio that will have a positive and a negative value. Using either positive value of the common ratio or the negative value will result to a geometric sequence when the geometric means are inserted. Now, instead of getting a sub 2, a sub 3, and a sub 4, we will just multiply the preceding terms by positive negative 3. Let us do that. 2 times positive negative 3, we have positive negative 6. And then positive negative 6 times positive negative 3, we have 18. Positive 6 times positive 3 is 18. Negative 6 times negative 3 is 18. Either ways, the answer will be positive. 18 times positive negative 3 is positive or negative 54. And then positive negative 54 multiplied by positive negative 3 will be positive 162. Hence, we were able to form two geometric sequences. The first one has terms 2, 6, 18, 54, and 162. This is where the common ratio is positive 3. The other one is 2, negative 6, 18, negative 54, and 162. This is where the common ratio is negative 3. Therefore, the three geometric means between 2 and 162 are positive negative 6, 18, and positive negative 54. Let us have one more example. Find the mean proportional between negative 10 and negative 1000. This time we're given two numbers, and if we're given two numbers, the mean proportional or the geometric mean, let GM be the geometric mean, is given by the square root of the two numbers A and B. Hence, the geometric mean between negative 10 and negative 1000 will be of negative 10 times negative 1000, and that is positive 10,000. And the square root of 10,000 is 100. This time, let us proceed to practice exercises. In the practice exercises, you will be given 15 seconds to answer. You may opt to pause the video if you need more time to answer, and play it again if you're ready to check whether your answer is correct. Let us have number 1. Find the 11th term in the geometric sequence 3x, 6x, 12x, 24x, and the pattern continues. Go. Time is up. Let us have the answer. Let us recall the formula for the nth term of a geometric sequence. The formula is a sub n equal to a sub 1 r raised to n minus 1. A sub n is the nth term, a sub 1 is the first term, and n is the number of terms. In this problem, we are given n is equal to 11 because we're looking for the 11th term. A sub 1 is equal to 3x, and r may be obtained by getting the ratio between two successive terms. Let us have 6x over 3x, hence r is equal to 2. Solving for the 11th term, we have a sub 11 equal to a sub 1, that is 3x, times r, which is 2, raised to n minus 1, that is 10. Hence, we have 3x, 2 raised to 10 is 1024. And 3 times 1024 is 3072x. Let us proceed to number 2. Find the mean proportional between 6 and 216. Go. Time is up. Let us see the answer. We are given 6 and 216, and to find the mean proportional or geometric mean between two numbers, we get the square root of the product of the two numbers a and b. So we have the square root of 6 times 216. We know that 216 is 6 times 36. 6 times 6 is 36, therefore we have 6 times 216 equal to 36 squared. Therefore, the geometric mean or the mean proportional between 6 and 216 is 36. Let us have number 3. Insert two geometric means between -5 and 135. Go. Time is up. Let us have the answer. We're given -5 as the first term. Then we're going to insert two geometric means, -135 as the fourth term. So if we're going to use the formula for the fourth term of a geometric sequence, we'll have a sub 4 equal to a sub 1 times r raised to 3. A sub 4 is -135. A sub 1 is -5, then we have r cubed. Dividing both sides by -5, we will have 27. -135 divided by -5, that is 27, equal to r cubed. Getting the cube root of both sides, that's cube root of 27 equals cube root of r cubed. Cube root of r cubed is r, and cube root of 27 is 3. Therefore, multiplying the preceding term by the common ratio, we'll have -5, the first term, times 3, that will be -15. -15 times 3, that will be -45. -45 times 3, that will be -135. We have a geometric sequence. Therefore, our answer, the two geometric means between -5 and -135 are -15 and -45. That will be all. Thank you for watching. Please subscribe for more math lessons.